Hello everyone, this is Zhuo Huang, and today I'm going to present our work on investigation on the band importance of face-aware speech enhancement. So this is the outline for my presentation. I'll first give a brief introduction on the background, then I will discuss the first experiment, which is about the band importance for face estimation. Then I move on to the second experiment, which is about the band importance-driven hybrid net for face-aware enhancement. And finally, I will draw conclusions. We have many studies that have shown the perceptual speech quality benefits that face-aware speech enhancement offers to normal hearing listeners, and its potential benefits to hearing impaired listeners. However, there are still some remaining questions, including, first of all, it is not clear if the estimated phase across different frequencies is equally important to speech quality for human listeners. And little is known about the underlying mechanism of speech quality judgment and how this phase from different frequency bands contribute to the perceived quality. So in this work, we first determined the band importance for face-aware speech enhancement by systematically removing the estimated phase information of high-frequency regions. We're doing this because we hypothesize that phase information from different spectral regions does not uniformly contribute to speech quality, as we conjecture that pitch perception plays an important role in quality judgment, as low-frequency sounds can usually invoke a strong pitch, whereas the high-frequency region will invoke a relatively not that salient pitch. And secondly, this work, we proposed a hybrid net that reduces the complexity of face-aware speech enhancement based on the findings of band importance of face estimation. So our first experiment is about the band importance for estimation, where we first generate speech samples by merging the enhanced speech produced by two independent speech enhancement algorithms, as illustrated in the figure here, where we have a face-aware, the complex CRN, and a face-insensitive speech enhancement algorithms. The CRN denotes the convolutional recurrent neural network with detailed structures illustrated here. So in particular, as shown in this flow chart, the low-frequency part of the face-aware speech enhancement enhanced speech are combined with the high-frequency components with the face-insensitive enhanced speech to generate this filter merge speech with a different crossover frequency. And by changing these low pass and high pass filtering, we can generate different versions of the filter merge speech. So here we have different crossover frequencies from 0 Hertz up to 4 kilohertz. So 0 Hertz is basically the face-insensitive enhanced speech. And we further conducted an online listening study of pairwise comparison between the full band face-aware enhanced speech versus the above-mentioned crossover, the filter merge speech with different crossover frequencies. And here is an illustration, an example of the online user interface. So in the online study, we recruited 20 participants in total for the first experiment, including 12 males and 8 females, aging from 23 to 58 years old, via Amazon Mechanical Turk. And in the online study, we further include an online headphone check stage to ensure that headphones were worn by all participants, where we utilize the Huggins pitch. Furthermore, I have prepared some audio demos for you to listen. Therefore, you may have a better idea of how this different crossover frequency influence the sound quality. So first of all, the face-insensitive enhanced speech, or the crossover frequency at 0 Hertz.
Serve the hot rum to get tired.
And the crossover frequency at 250 Hertz.
Serve the hot rum to get tired.
4 kilohertz.
Serve the hot rum to get tired.
And the full band face-aware enhanced speech.
Serve the hot rum to get tired.
So the results for the first experiment is provided in this figure here, where we are showing you the D prime values versus different crossover frequencies. The D prime values is a psychophysical measure of discriminability. And here, a large D prime value indicates better discriminability, a positive value indicates a preference towards the full band phase-aware enhanced speech for our first experiment. And a D prime value close to 0 indicates that the listeners cannot reliably differentiate the difference between the two stimuli. So for the results here, we notice that for low crossover frequencies, there is a strong preference for the full band phase-aware enhanced speech over the filter merged speech, reflected as the large positive D prime values. We also found that listeners cannot reliably differentiate the two enhancement models with high crossover frequencies. And this means that estimating phase information at high frequencies does not seem to improve the speech quality. And next, I'm going to introduce our second experiment about the band importance-driven hybrid net for phase-aware enhancement. And this is inspired by the finding from the listening experiment. And here we introduce a novel hybrid speech enhancement framework with reduced network complexity. The proposed framework is illustrated in this figure on the right side, where it consists of a phase-aware CRN that estimates the low-frequency speech, and another phase-insensitive CRN that processes the high-frequency components, with additional residual connections to enable information sharing across subnetworks within the encoder, recurrent layers, and decoder. And for our second experiment, we further conducted another online listening study of the pairwise comparison between the hybrid net enhanced speech versus the different configurations. We used the same user interface as the first experiment, and we further recruited an additional 20 subjects, including 12 males and 8 females from Amazon Mechanic Turk, aging from 23 to 46 years old. I also prepared some audio demos for the different systems. So first of all, the hybrid net enhanced speech.
Please sign deeply into the soft terms.
And the phase-sensitive enhanced speech.
Please sign deeply into the soft terms.
And the filter merge speech at 4 kilohertz.
Please sign deeply into the soft terms.
Finally, the phase-insensitive enhanced speech.
Please sign deeply into the soft terms.
So in this figure, I'm showing you the results for our second experiment. And here, a higher D prime value above 0 indicates that the stimuli generated by the proposed hybrid nets are more preferred. We also found for the second experiment, we found that the average value is above 0 for all comparison models, suggesting that the proposed hybrid net produces enhanced speech with better perceived quality. We also found that listeners prefer the hybrid net enhanced speech even compared to the full band phase-aware CRN. And this is confirmed by two-tailed t-tests showing significant differences between the D prime values and 0. In this table, I'm showing you the network statistics of different systems. And in terms of the metrics, I'm providing the model size, the MAC operations, as well as the inference speed. So we found that the proposed hybrid net is approximately half of the size of the original phase-aware CRN, and it achieves a relative 38% reduction in MACs for the proposed hybrid net. However, the inference speed for the proposed hybrid net is slower than the other speech enhancement systems. And this is likely caused by the two computation flows and their interactions for the low frequency and high frequency processing. And this gap could be potentially alleviated by optimizing the parallel process between the two computation flows. So in conclusion, we found estimating phase is mostly important at low frequency regions for human perception of speech quality for normal hearing listeners. And we proposed a hybrid phase-aware speech enhancement framework with reduced network complexity. And finally, the hybrid net achieves even better performance than the original phase-aware system. And this could be caused by the more accurate estimation of phase component at the lower frequency region of HybridNet compared to the original phase-aware system. And that's all. Thank you everyone for your attention.